Hi, my name's Caleb, and we're going to be looking at the second derivative test and how to find local maximums and minimums. So if you're given a function here, f of x equals 1/3 x cubed minus 1/2 x squared minus 6x plus 9, the first thing you want to do is find the derivative of that function. So in this case, you just go term by term, be x squared minus x minus 6. Alright, the next thing you want to do is factor this. And what you get is x minus 3 times x plus 2. And to double check your work, you find that this is equal to, you just FOIL this, minus 3x plus 2x minus 6, which is thankfully equal to x squared minus x minus 6. Okay, so now you have the factored form of f prime of x, which is our derivative. And for the second derivative test, it states that a local maximum or minimum the derivative of the function will be 0 at those points. So you want to find an x for which this term will be 0 and this term will be 0. So in this case, you get x equals 3, and for this one, you get x equals negative 2. Alright, the next thing we're going to do is find the second derivative. So we go back up to this function, and you'll get 2x minus 1. Alright, so now what we do is plug in each of these x values into f double prime of x to determine the concavity. So f double prime of 3 will be 2 times 3 minus 1, which is 6 minus 1, which is 5. And then f double prime of negative 2 will be 2 times negative 2 minus 1, it's negative 4 minus 1, negative 5. Okay, so for x equals 3, f double prime is greater than 0, so that means concave up, which means that this is a local minimum. And for x equals negative 2, f double prime is less than 0, so it's concave down and is a local maximum. Because remember, if something is concave up, it looks like a U, and your point is going to be here. Like this would be f of x right here. You see how that is lower than all the other values, and this would be, this is your x-axis. This would be x equals 3. And then for the case of x equals negative 2, let's say this is farther to the left. So let's say that say the function looks something like this. If this is negative 2, this is the 3 that's shown close up over here. This is still f of x. That would be our local maximum. See how that's concave down? It looks like an inverted U. And this would be concave up, which is shown closer up here. So those are your local maximum and your local minimum. And that's how you find them.